Hi, my name is Ian, and today we're going to be dealing with algebraic expressions. Now, algebra came along in Egyptian times, a long time ago. It's been around for so many years, but modern algebra has only really been developed since the 19th century. So for thousands of years, they were battling. And it's only now that guys like you and me are able to do really advanced algebra thanks to the guys who developed it from the 19th century onwards. Let's dive straight in. Multiplying binomials by trinomials. So the first thing is multiplying out brackets. The next major focus that we're going to be doing is factorizing. 3 different kinds of factorizing. Trinomials, looking for sum and difference of 2 cubes, and grouping. We're also going to be looking at fractions and how we deal with fractions. Also within this, we're going to have to be doing sum and difference of 2 cubes, the factorization of that. That's new in the syllabus, new in the CAPS document. It was there a couple hundred years ago, but it's come back in and it's really useful. So let's get straight in to multiplying out. What I'm going to be doing is I'm going to be doing a little bit of revision so that you can catch up and make sure you're up to speed, and then you'll see that it's actually quite easy and quite straightforward. Let's get started. In this first one, we're going to be looking at the distributive law, and they ask us to simplify. Now, what simplify really means is get rid of our brackets. Get rid of the brackets. So, what we're going to be doing is we're going to be distributing. And some of the girls in my class call this rainbow sums. So the first little rainbow is 2a times a. The second little rainbow is 2a times minus 1. Let's remember that that minus hangs around and is part of that minus 1. We then have the minus 3 times the a squared and the minus 3 times the minus 1. Well, that gives us 2a squared. Our next product gives us minus 2a. Our third one, minus 3a squared, and positive 3 for our constant term. And all we do is simplify them and add like terms. Now, I know that you can do that, and you probably did that last year. But as I said, this is revision, because what we're doing this year just builds on what we've done so far. Let's have a look at the second example. Here is 2 binomials. Binomials because they're 2 terms in each little bracket. And we're going to be finding the product. Well, once again, we're going to be using rainbow sums. The first times the first. We're going to be doing the outers, first times the second. We're going to be doing the inners. And we're going to be doing the lasts. And what you can see is I've got a little acronym called FOIL. So, here we go. When you have 2 binomials and you want to multiply them out, firsts, outers, inners, lasts. Make sure that you don't leave anyone out. I know that some of you prefer to draw in your little rainbows. That's absolutely fine. Let's have a look how the solution looks. Right, here we go. 3x times 5x, that's our firsts. 3x times 8, that's our outers. Minus 2 times 5x, that's our inners. And minus 2 times 8, that's our lasts. Now, I don't need to talk you through the actual multiplication of those 4 terms, and I know that you will gather like terms and add them to get your final answer. So far, so good. FOIL, 2 binomials multiplied together, firsts, outers, inners, lasts. Next example. Here we have a binomial by a trinomial. 2 terms in the bracket, 3 terms in the bracket. Well, do you think that this is going to be any different from what we've just done? Remember, every term in the one bracket had to be multiplied by every term in the second bracket. Exactly the same thing happens. It just means we're going to have a lot more multiplying to do. I'm going to draw in my rainbows, and then we're going to have a look at the solution. So that is going to have to be multiplied by that, and by that, and by that. And the negative 1 is going to have to be multiplied 3 times, just like I've shown there. Here we go. As you can see, the answer is quite long, so it's going to be done in 2 lines. There's my x times my x squared, my first rainbow. My x times my minus 2x squared to give us that solution. My x times my 1 to give us our x. And that's the first 3 bits. That's the upstairs rainbows. The downstairs rainbows will be the minus 1 times x squared, the minus 1 times negative 2x, and the minus 1 times plus 1 to give me that. Those 3 are the downstairs or upside down rainbows. All I've got to do is simplify, add like terms, and out pops a 4-term expression known as a cubic, because it has an x to the power 3. Now, don't get worried about this. It's just a bit bigger. Just like you were quite a lot smaller last year, and this year you're quite a lot bigger. So we don't only deal with binomials this year, we might go to trinomials or brackets with 4 terms. Let's have a look at the next example. Well, here we go. It's a bracket squared and then something multiplied into our bracket. Now, before I dive into that, I need to give you a little recipe for doing it quickly. Remember, if you're going for a good mark, you need to use these recipes, these shortcuts. It's going to save you time on the easy stuff, so you've got more time on the difficult stuff. I'm going to do it on the side over here. If I had x plus y all squared, it's the first squared, the first times the second times 2, and the second squared. Now, I think that's a lot easier than having to write the bracket out twice, do our rainbow sums, and then gather like terms. I'll run through it again with another example. Here we have 2x plus 3 squared. My little recipe is first squared, first times second times 2, second squared. And there I go straight to my answer. If you wanted to write the bracket out twice, that's absolutely okay. So, back to our example over here, which has got a perfect square in it there. So, first squared, first times second times 2, second squared. That's my bracket multiplied out. Now, I'm going to go and put our rainbows in for the second bracket. So we got minus a squared minus 4a. And all I've got to do is gather like terms. Well, my a squareds disappear. I have minus 4a minus another 4a, which gives us minus 8a, and my constant term in this case is plus 4. Just to reiterate, this little trick over here saved us quite a lot of time. Moving to the second example, you can see that it is a binomial multiplied by a trinomial. 3 rainbows on top, 3 rainbows at the bottom. I'm going to draw them in, and then we will do them and then gather like terms. So, here we go with our rainbows. There's the first one, the second one, and the last one. And the downstairs rainbows happen just like there. Right, 5 times 5a times 25a squared. What would that give us? 125a cubed. 5a times 20a gives us positive 100a squared b. Our 5a times our 16b squared gives us our 80ab squared. Now that's our upstairs rainbows. Let's do our downstairs rainbows. Negative 4b times 25a squared, negative 100a squared b. Negative 4 times 20ab would give us our negative 80ab squared. And our negative 4 times 16 will give us, yes, let's hear you from there, 64, negative 64b cubed. How about now gathering like terms? Well, isn't that amazing? Those two disappear, and those two disappear as well. So my final answer is 125a cubed minus 64b cubed. Now, I don't know if you spotted a pattern there, but our answers are two perfect cubes. Now, later on when I come to factorization of perfect cubes, you might like to recall this question and have a look at it. On to number C. Well, number C is quite interesting because I noticed from my grade 9 work a wonderful pattern with those two brackets. So what I'm going to do is I'm going to write those two brackets next to each other first before I multiply out, because that is the difference of two squares. And my middle term, my m, is 0. So this makes it a lot simpler than having to multiply out two brackets, then the other one into it. And have a look at this. What have we got? We've got another difference of two squares. So I have 16m squared minus 81. And there's my final answer. Moving on to our last example. Now, there are actually two different ways of doing this, and I'm going to do them both. One is going to be let's start at the beginning and plod through the process and get to the end. The other one, which I hope you guys, you really good guys who are really good at maths, are going to do, is to take a moment, have a look at any patterns that develop, and then tackle the question. I'm going to do it straightforward and then with a little bit of a twist. Here we go. Well, I'm going to draw my rainbows in like a good boy, draw them in again, and it's going to be quite long. I'll get my a squared, I'll get my plus 2ab, and I'll get my plus ac. And then this is going to have to be multiplied by all three as well. So I'm going to get my plus 2ab and my plus 4b squared and my plus 2bc. And then my minus c is also going to have to be multiplied by all three. So minus ac, minus 2bc, and minus c squared. And that's quite laborious, and I'm sure you agree with me. Well, let's quickly gather like terms. A squared, I've got 2ab's and another 2ab's to give me 4ab's. I've got an ac term and an ac term over there that would disappear because they would cancel each other out. I've got a minus 2bc and a minus 2bc over there, which would cancel each other out. So what I'm left with over here is plus 4b squared minus c squared. Now, when I say the problem with this technique is, it's not really a problem, it's you've got to be very, very accurate in order to get the right answer. One little slip, and it's going to be a mistake. What I'm going to do is I'm going to do it again in another way. Right, I'm going to write this question out again, and then I'm going to insert some brackets within the brackets that exist. And what I'm going to show you is if I group those two together and those two together, That and that are exactly the same. That bit and that bit are exactly the same. And I've got the difference of 2 squares. So I could take my first bracket squared and subtract c squared. I'm sure you would agree with me that that's a lot quicker. So here we go. We're just going to finish it off with our shortcut for bracket squared as well. First squared, first times second times 2, that gives us 4ab, and second squared, 4b squared, minus c squared. And guys and girls, it's exactly the same answer as we got over there, those two over there. Right, some of you are going to say, can we do it both ways? Absolutely yes. This is grade 10, and that's what's so good about grade 10, is you can do the same question in a couple of different ways and land up with exactly the same answer. That's what we're going to do with expansion, or what's also called simplification, removing brackets. We're going to go to an ad break, and when we come back, we're going to tackle factorization. Welcome back. As I said just before the ad break, we're going into factorization. Now, before I tackle it, you've got to realize that just like addition and subtraction are opposite or inverse operations, multiplication and division are inverse operations, so are expansion and factorization. And let's have a little look at the diagram over here. If we take that expression over there and we expand it, or we do our rainbow sums, we land up with that. There we go. If we factorize, we put it back into the brackets and we land up with what we started with. So factorization and expansion are opposite operations. Now, where does this actually help us? Well, once you've factorized something, you could just do a quick expansion and see that you land up with what you started. It's a double check. Make sure you get the right answers. A couple different kinds of factorization. We're going to go through all of them in detail. Here we go. The first one, taking out a common factor. We'll touch on grouping and also changing the sign. Well, here we have to factorize, and what we notice is this common factor, the common bracket, is not exactly the same. So we're going to use what's known as switch around. If I switch around inside the bracket, the sign switches around outside the bracket. So essentially, and here it is typed up for us, if I do my switch around, I land up with a bracket that is exactly the same. What was a negative outside becomes a positive, and what was a 2 minus a becomes an a minus 2. Just a word of caution, the switch around works for negatives only. In other words, in the bracket, a minus 2, 3 minus x. If it was plus, 3 plus x and x plus 3, exactly the same thing. You could switch that around without worrying about changing the sign outside. Let me reiterate. If it's negative inside, change the sign outside, switch around inside. Let's finish off this question. Here we have our common bracket. So what we do is we write down our common bracket and everything else that's left. I'll repeat that. Write down our common bracket and everything else that's left. That's using a common factor or a common bracket. Moving on. Difference of 2 squares. Now, I mentioned difference of 2 squares when we were doing expansion. It's really convenient to recognize a perfect square minus another perfect square. Makes life a lot easier if we can recognize it straight away. Let's have a look at our question. A squared minus 4. It goes to 2 brackets, a plus 2, a minus 2. That's it. That's as easy as it is. Now, some of you might be saying, are you sure? What about our middle term? Well, let's do our double check on the side. A times A times minus 2, plus 2 times A, plus 2 times negative 2. Gives us A squared minus 2A plus 2A plus 4. Aha! The middle terms disappear, and we're left with A squared. Oh, my apologies. That should have been a negative. A squared minus 4. Exactly what I started with. So as I said to you a few minutes ago, factorization and expansion, opposite operations. And you might like to double check yourself, just like I did. Let's have a look at another question. This is a challenge question, and it's got difference of 2 squares in it. But it's also got a bunch of other funny stuff over here. I know that you've recognized already that that bracket and that bracket are the same. So what do we do in the case of a common factor that's a bracket? Write down the common bracket and everything else that's left. Now, is that fully factorized? And one thing you will realize when you write your exams is if they say factorize, I suppose you could just take out a 1 and put brackets around everything because you've factorized with a 1. What your exams are going to say is factorize fully. And then you've got to resolve this into all its factors. So the question's not quite finished yet. Let's get it finished. This first little bracket is also a difference of 2 squares. I've recognized that A squared and 4 are perfect squares. So that goes to A plus 2, A minus 2. There we go. Now it is finished. We've resolved it into all its factors. Moving on. Trinomials. Trinomials, 3 terms. I do this with a little recipe of recognizing 4 types. I find that this is the easiest, and I'll take you through all 4 types. Well, here we have a look at what I need to remember. Plus, plus, plus goes to plus, plus. That's a type 1. Plus, minus, plus goes to minus, minus. That's type 2. Plus, plus, minus, my biggest factor gets the plus, and a plus, minus, minus, my biggest factor gets the minus. The other thing is that I'm looking for the sum, and there it's shown by the plus, of factors to give me the middle term, the sum of factors. And here, the difference of factors to give me the middle term. If we remember that, we know what our answer is going to look like, and we can set up our brackets before we even worry about resolving the bits into its factors. Let's have a look at number 1. Well, it's a plus, plus, plus. Type 1, it's going to have to go to plus, plus. So before I do anything else, I can set up my brackets. What 2 variables multiplied together give you x squared? Yep, it's x and x. Now what I do is I look for the factors of 15. Well, 15 times 1 and 3 times 5. And if I remember, I'm looking for the sum of factors to give me my middle term. Well, does 15 and 1 give me 8? No, not a chance. So we're going to have to land up using 3 and 5. And there we go. For those of you who don't believe it's that easy, well, let's double check. X times x is x squared. X times 5 is 5x. 3 times x is 3x. And 3 times 5 is 15. And that gives me x squared plus 8x plus 15, which is what I started with. So here we go. We know that we are correct. Let's move on to question B. Well, it's got a plus, minus, minus. Aha, it's a type 4. There we go, type 4. The biggest factor is going to get the negative. Well, let's set it up. We know one bracket's going to be a negative and the other bracket's going to be a positive. Two variables multiplied together to give me x squared, x and x. Let's look at 12. 12 is 12 and 1, 2 and 6, 3 and 4. What difference of these numbers is going to give me my middle term? Well, the difference between 12 and 1 is 11. That's not going to help me. The difference between 3 and 4 is 1. That's not going to help me. The difference between 2 and 6 is 4. That's where we're going to go. Biggest factor minus 6, 2. There it is, factorized for us. This seems to be quite easy. Let's move on. Well, plus, plus, minus. That is going to be a, let's double check, plus, plus, minus, a type 3, where our biggest factor is going to get the plus. So we know it's going to be two brackets. The biggest factor is going to get the plus, and the smallest factor is going to get the minus. Yep, you guessed it, x and x. 12. We've already done 12. Let's change colors so that we can work it out. We need positive 4. Well, the difference, nope. The difference, yes. It's going to be 2 and 6. Remember, the biggest factor is going to get the plus. And there we go, factorized. Last question in this set. Plus, minus, plus. Type 2, both our brackets are going to have a minus. And as we guessed, x and x. Now 9 is quite cool because it's either 9 and 1 or 3 and 3. And remember, we said this is a type 2, so we're looking for the sum of numbers to give us negative 6. That's not an option. It's got to be that one. There we go. Now, some of you might say, should I not write that a little neater, a little prettier? And I would say, yes, as a mathematician, you should. It's not wrong to leave it as x minus 3, x minus 3. But if you want to really impress your teacher, showing that you know exactly what's going on, here, let's finish off the answer. That's going to give us x minus 3 all squared. And that's the best way we can answer that question. Let's move on. Here we go to the last kind of factorization we're going to be dealing with. Now remember, factorization is actually just a tool. When we start using factorizations, we're going to get huge questions where we're going to have to do factorization as just one of the little things within it. That's why, as a skill, it's done early in the year so you can acquire the skill so you can use it. Let's look at sum and difference of two cubes. Cubes like 8, 27, a cubed, b to the power 6. Here we go. If we take this question over here, a binomial multiplied by a trinomial, and we do exactly what we did a little while ago, we land up with the sum of two cubes. Now, I asked you to remember that. So if we expand this with rainbow sums, we get that answer. So what happens if we go backwards? We factorize and we get that. Let's have a look at another one. Here we take a binomial and a trinomial, and we multiply out and we do all our rainbow sums and gather like terms, and we land up with the difference of two cubes. So that factorized form is exactly the same as that expanded form. To summarize, we've got x cubed plus y cubed to give us those two brackets, and x cubed minus y cubed to give us those two brackets. I'm going to do a couple of examples for you. If I had a cubed minus 8. Now, we all know that 8 is 2 cubed. So that's where my perfect cube comes in. So here's a little rhyme, and I'm going to write it on the screen once I've finished it. It goes first, second, first squared, first times second, second squared. Try and get your tongue around it. I'm going to write it down as we go along. First, second, first squared, first times second, second squared. Now, you might say, what relevance does that have to what we're doing? Well, first, second, it's in the first little brackets, it's our binomial. First squared, there it is. First times second, there it is. Second squared, there it is. But what about the signs? Well, if it's a plus, it's going to go plus, minus, plus. And if it's a negative, it's going to go minus, plus, plus. So, back to our example over here. A cubed minus 8. Small bracket, big bracket. First would be a, second would be 2. First squared, so a squared. First times second, second squared. And all I've got to do now is put in my signs. Because it's negative, it goes negative, positive, positive. And that gives us our factors of a difference of 2 cubes. Let's give you another one. How about x to the power 6 plus 27? Yes, x to the power 6 is a perfect cubed. It's x squared times x squared times x squared. And what's the cube root of 27? Yep, it's 3. So our first would be x squared. Our second would be 3. Let's tackle it. Well, it's going to be small bracket, big bracket. And our first is x squared. Our second is 3. Our first squared is x to the 4. First times second, 3x squared. And second squared would be 9. Because it's a plus, it'll go plus, minus, plus. There we have it. The factors of the sum of 2 cubes. I'm going to do one more that's got a slight twist in the tail. And here we go. It's going to be x to the 3y minus 8y. What am I going to do there? It's not the difference of perfect cubes yet. What are you going to do first? Absolutely correct. Take out the common factor. Let's do that, and then we can factorize our perfect cube. Well, we take out our common factor of y, and we were left with x cubed minus 8. And that gives us small bracket, big bracket. Well, our first would be x, because the cube root of x cubed is x. Then we would have a 2, because the cube root of 8 is 2. First squared, first times second, second squared. And because that's a negative over there, negative, positive, positive. Guys, that's all there is to cubic factorization. It's a pattern. Just like we had patterns with trinomials, so we have patterns with cubic factorization as well. And remember, maths is also a lot of learning. So if you learn your patterns, you'll see them and get everything right. Let's move on. Here are a couple of examples we can work through. 16 minus x to the power 4. Now, I know that some of you are going to say, let's take out a negative and work with x to the 4 minus 16 first. If you want to do that, that's fine. If you don't, not a problem. Well, we know that that is a perfect squares, so we get x squared plus 4, x squared minus 4. And are we finished? I can hear some of you mumbling saying no, absolutely correct. The second bracket can still be factorized. So this one can go even further to x squared plus 2, not x squared plus 2, x plus 2, x minus 2. And now it is fully factorized. I want to just throw a little challenge out to some of you and say, could we actually factorize x squared minus 3 and put that into two brackets? Well, yes and no. If you wanted to work out the roots of an equation, if that was turned into an equation, you might like to factorize it. This is just being a little bit smart. Let's have a look. Well, an x and an x. Two numbers multiplied together to give you 3. Well, we know one's going to be plus and one's going to be minus. How about root 3, root 3? Now, let's be honest with each other. You're not going to get a question like that in the exams, but it might be nice just to impress people. Let's move on to the next question that was set for us. Here we have m squared minus a ninth. Now, before we tackle that, a third times a third is equal to 1 over 9. Multiply tops, multiply bottoms, and we get our answer. So we know that this is the difference of perfect squares. Two brackets, an m and an m, a third and a third. One's going to be plus, one's going to be minus. Fully factorized, there we have it. Now I know that some other of you might like to take out a factor of a ninth and then have 9m squared minus 1. Okay, let's do that. Some of you might like to take out a ninth and have 9m squared minus 1. Do I land up with my question when I multiply this out? Absolutely correct. What it does give us, it gives us difference of perfect squares, 3m minus 1, 3m plus 1. And both those answers are the same, even though they look slightly differently. They are the same, they're numerically equivalent. And it's up to you to work out which one you would prefer to do. Remember, grade 10, you have the choice. On to question C. Now over here I have a 9 and I have an 81. Yes, they're both perfect squares, but wouldn't it be easier if I took out my 9 and I'm left with b squared minus 9 to start with? Many, many years ago, I taught the 3 members of TKZ in my grade 10 class at Saints. And they came up with a song which said, first you take out the common factor, factorization. Always look for that common factor. I've never forgotten that song. It was a wonderful day. Let's carry on with the question. So there we have 9 and we have the difference of two squares, b minus 3, b plus 3. And it's finished. If we had taken that, and I'm going to do it an alternate way, and left it and gone straight into our factorization of 3b minus 9, 3b plus 9, you would have noticed that that wouldn't have been fully factorized, neither the first bracket nor the second bracket. And we would have had to take out a 3 from the first bracket and a 3 from the second bracket, and then sort out our answer afterwards. And look, we have exactly the same answer as what we started with. It just took a little longer. Okay, let's go down to our last question. A b squared, a b, and a constant. Looks like it's going to be a trinomial. Also, it's a plus, plus, plus. Type 1. That's going to give us a plus and a plus. I've also checked that there are no common factors because we have to take out that common factor first. Have a look at this. This is actually quite phenomenal. Your first term and your last term are perfect squares. That might give us a bit of a hint. So, I'm going to dive in and just test. How about 4b and 7 as a perfect square, giving us 56b in the middle? This is a test. Well, 4 sevens is 28. 4 sevens is 28. I'd be left with a 28b over there and a 28b over there, which does give me my 56b over there. That was one lucky guess. So, it's going to be 4b plus 7 all squared. Now, what would have happened if it hadn't been a perfect square? Well, pull a line through it and try another set of numbers. Remember, making a mistake isn't a problem. It just means that's not the right answer. And now you can progress and find the right answer. Let's move on. Couple more factorization bits and pieces. Well, here we go, taking out a common factor. We have our a squared minus 6ab plus 9b squared. What type is this? It is a type 2, plus, minus, plus. Two brackets, both with a minus. Well, multiplying a times a will give me my a squared. And don't panic if you see a b squared over there. The b squared, we're going to handle exactly the same as we did the a. Let's fill it in before we even worry about the numbers. So, as we said, what are the factors that multiply together to give you 9? Well, 9 and 1, 3 and 3, and remember it's type 2, so they have to add to give us our middle term of 6. 9 and 1, not an option. 3 and 3, there we go. So we can fill in our answer and a minus 3b all squared. And once again, I'm going to be a good boy and write it in best possible notation. Wasn't that cool? Two factorizations in one. First a common factor, and then a type 2 trinomial. Let's carry on. Question F over here looks like quite a simple trinomial. Type 4, so I know the biggest factor is going to get the negative, and the other factors going to get the positive. Right, let's have a look at two numbers multiplied together give you 30. Well, 30 and 1 is our one option. 2 times 15 is another option. How about 3? 3 times 6 is another option. No, it's not. 6 3s are not 30. So there's an error. So what would it be? 3 times 10. Do we need to carry on? Well, let's have a look. 6 and 5 would be another option. Remember, the difference has to give us our 7 because this is a type 4. Well, 5 and 6, difference is not 7. 30 and 1, difference is not 7. 15 and 2, likewise is not 7. Haha. There we go. 10 and 3, the difference is 7. Type 4, biggest factor, gets the negative. And there I factorized it. Going on to question G. Is there a common factor? Well, some people will argue with you and say, yes, there is. And as it stands, we got a p cubed. Is 3 a perfect cubed? No, not today, not tomorrow either. So I'm going to take out a 3 and let's see how that fraction is transformed into a perfect cube. Here we go. Right, so what we're going to do over here is we're going to take out a factor of 3. P cubed. Now 3 times what is going to give me a 9th? You guessed it, 1 over 27. And yes, 1 over 27 is a perfect cubed. 1 over 3 cubed is 1 over 27. So, here we go. Small bracket, big bracket. First, second, first squared, first times second, second squared. And all I've got to do is put in my signs. Negative, positive, positive. What you might like to do, and this is at your discretion, you might like to write this middle term as p over 3 instead of a third p. Either of those two will get you full marks. It just depends what you as a grade 10 feels like. And remember, you have the choice. On to question H. Now, you'll notice over here we got a bracket cubed, and there we got a bracket cubed. And goodness me, that is a perfect cube. So yes, this is quite a challenging question. We've got a perfect cube, which is a bracket, and a perfect cube, which has a number and a bracket. So, we have to be rather meticulous about this one. Small bracket, big bracket, and you can see it's a small bracket and a really big bracket because we've got to put brackets inside brackets. Here we go. Well, first will be our 2 plus p. Second will be our 2 into p plus 1. First squared will be 2 plus p squared. First times second will be 2 into 2 plus p and p plus 1. And our second squared will be 4 into p plus 1 squared. And there endeth our second bracket. Let's put our signs in. Because our sign over there is negative, we have negative, positive, positive. My word, what an enormous question to handle. So, let's tackle it. In this first bracket, I'll have 2 plus p minus 2p minus 2. And in my second bracket, I'm going to have, and this is where doing it with a shortcut really helps. First squared, first times second times 2, second squared. Over here, I'm going to do it in 2 steps. I'm going to FOIL it out. 2 times p is 2p. 2 times 1 is 2. P times p is p squared. P times 1 is p. And shortly, I'm still going to have to multiply all that by the 2. My last term is also going to have to take 2 steps. 4 times my bracket squared. First squared. First times second times 2. Second squared. Now, some of you might be saying, why didn't you multiply the p in 4? Oh my goodness, have you forgotten BODMAS? Or, as we use in senior high, BEDMAS? Exponents, that's the little squared, before the multiply, in this case the 4. So we have to multiply those brackets out and then distribute the 4. Let's carry on. Well, in the first bracket, I'm going to gather like terms, and I'm left with a negative p. In the second bracket, I'm just going to have to work all this out before I can gather any like terms. And here we go along, merrily on our way, dealing with the second bracket, and now with the last bracket. Finishing off there. Okay, let's tidy up this second bracket. You see how accurate you have to be, people. If you aren't accurate, oy vey, you lost. P squareds. Well, I've got 7 p squareds. Let's have a look for p. I've got 4 there, and another 4 give me 8, and another 8 give me 16, and don't forget those last 2, I get 18p. And my constant terms, 4 plus another 4 to give me 8, plus another 4 to give me 12. And there we go. We have taken this delicious monster over here, which had 2 brackets cubed, and we've factorized it into its factors. And there we go. What we're going to do after the break is we're going to move on to fractions. So stretch your legs, have a drink of water, and when we come back, fractions, where we're going to use expansion and factorization. See you shortly. Welcome back. What we've done so far is we've looked at expansion, or removing brackets. We've looked at factorization, putting things back into brackets. And now we tackle one of the uses of these 2 skills, dealing with fractions. Yes, fractions come to haunt us again, and we have to deal with the 4 operations of fractions. Let's get straight into it. Well, first of all, we're going to look at multiplying and dividing fractions. And here we have a worked solution. Just remember, with fractions, you have to factorize fractions fully first before further work. I'll say it again. Factorize fractions fully first before further work. So there's our first numerator, and they've factorized it. There's our denominator, and they've factorized it. There's our second numerator, and they've factorized it. And our last denominator, and they've factorized it. Now, because this is a division, what's going to happen? We're going to find the reciprocal. Reciprocal means top becomes bottom and bottom becomes top. Right, so here we're going to do the reciprocal, and here we go. Now, is this our final answer? Absolutely not. That factor and that factor can fly away. That factor and that factor can fly away. And have a look. X plus 2 and x plus 2 as a factor can also fly away. And oh my goodness, so can x plus 1 and x plus 1. What am I left with? I'm left with the answer of 1. Now, guys and girls, please remember, with fractions, you factorize fractions fully first before further work. And once you've done that, remember, only factors can fly. Just make fractions a whole lot easier. Let's go on to our next question. Here we're going to add and subtract. Now remember, back in the dark ages when you were in primary school and you had something like that, you had to have a lowest common denominator, and you multiplied things out to get, in this case, 3/4. What I'm trying to emphasize is that lowest common denominator. Now, in the example I used, I had a denominator of 4. Could I have used a denominator of 8, 400, or 12 million? Absolutely yes, I could have. Would it be the simplest form when I get my answer? No. Would it have been easy if I'd used 12 million as my denominator for a half plus a quarter? Absolutely not. That is why we try and use the lowest common denominator. Just makes life a whole lot easier. Let's have a look at the question. Well, here I have to add and subtract. Is that factorized? Not yet. Is that factorized? Not yet. So step one, I have to factorize the numerator and the denominator. Factorize fractions fully first before further work. Well, there we go, our x plus 2 and our x minus 2, which came from our x squared plus 4. That middle term, the denominator is factorized, and there I have my x plus 2, x minus 2. Right, so what we've done is we've factorized our numerator and our denominator, and we have the lowest common denominator of x plus 2, x minus 2. Let's just double check that. That times something will give us that. That times something will give us that. And that times something will give us that. And it's the lowest form that we've got. Once again, we could have used anything as our denominator as long as it included the x plus 2 and the x minus 2. We could have had an x plus 3 or an x minus 7. Would it have been the lowest one? Absolutely not. Try and keep it simple. Lowest common denominator. Let's move on. So there we have our lowest common denominator, and we're going to write this as one fraction. There's our first term, there's our second term, and it's multiplied by our missing little bit out of our denominator, and there's our third term. We multiply things out, add like terms, and we land up with an answer. Is that our final answer? Well, can we factorize this slightly further? Yes, we can factorize it. Do any factors fly away? No. There's our final answer. I would give full credit for that or for that because there's no further simplification that can take place. Right. Here we have a fraction, and we're going to show off our skills of factorization because we're going to factorize our fractions fully first before further work. And hitting straight in, I have a sum of perfect cubes. P first, second, first squared, first times second, second squared. Popping in my signs, plus, minus, plus. At the bottom, I've got a p squared. Let's look at our second term. Right, I can take out a 3 as a common factor, and I'm left with a p minus q. And at the bottom, I've got the difference of two squares, p plus q, p minus q. There we go. I have now factorized my fraction. Only factors can fly. That factor and that factor can fly away. That factor and that factor can fly away. Anything else? Nope. So, here we go. We write down everything else that's left. We've got a 3, we've got a p squared minus pq plus q squared, and at the bottom, we've got a p squared. Now, someone's going to say to me, can't this p squared over there and that p squared over there cancel? And I'm going to say to you, no, because they're not factors. The p squared on top is part of a bracket. Only factors can fly away, so we've got to leave it where it is. And that was our final answer. Back to screen. Here we go. That is our final answer. Let's do another one. Simplify the following. Well, once again, it's a fraction, so we have to factorize our fraction fully first before further work. Difference of two squares, p plus q, p minus q. That's our numerator. At the bottom, our denominator. I'm sure you don't mind if I reciprocate and factorize at the same time. There's our numerator that becomes our denominator because it was a divide. And at top, I can take out a common factor of p, and I'm left with p minus q. Well, what can fly away? That factor and that factor can fly away. That p and that p can fly away. And what am I left with? I'm left with a p minus q and a p minus q. Oh my goodness! A p minus q all squared. The best way of writing our answer. Just to reiterate, factorize fractions fully first before further work, and only factors can fly. Let's do another question. Well, this is a subtraction question, and I'll need to factorize that before I can sort out what my denominator is going to be. And it's the difference of two squares, a minus 7, a plus 7. Okay, what am I going to choose as my denominator? Well, a plus 7, a minus 7 includes both our factors. And actually, I call that my flower number because it's going to make fractions blooming easy. Here we go. A plus 7, a minus 7 as my denominator. What's the missing bit? A minus 7 over there. Is there anything missing over here? No. Some of you are going to say to me, why did you put it in a bracket? And I'm going to say, watch out for minuses. Beep, be careful. You're going to have to distribute those minuses. All right, so on top, we've got an a minus 7, minus a minus 7, and at the bottom, we've got an a plus 7, a minus 7, and moving across here, we'll have negative 14 over a plus 7, a minus 7. Can anything factorize and disappear? Absolutely not. So that's our final answer. Let's move on to our last question on this slide. Yes, we're going to have to factorize. 1 minus 2a on top, and we'll have a 2a minus 1, 2a plus 1 in our denominator. Ooh, perhaps we want to look at simplifying something there before we work out our difference in this question. Okay, here we'll have a 2a minus 1 and an a minus 1. That's our trinomial factorization. And on top, 2a minus 1. And the last little number doesn't need any factorization. Now, let's just have a look at this. A minus 1, 1 minus a. Very similar. And how about this over here? My 1 minus 2a and my 2a minus 1. Remember a little while ago, when we were doing factorization, we used switch around when it was a negative. I'm going to use switch around to help us simplify the question before we even get a denominator. Here we go. I'm going to write this as minus into 2a minus 1. And that's going to be over 2a minus 1, 2a plus 1. Here, nothing can help me, so I'm just going to have to carry on as is. But in my last term, if I make it positive outside, I can switch around inside. And have a look. That really helps us because that bracket and that bracket, as factors, are exactly the same. That one can kill off that one, just technically for the moment. So let's have a look at our common denominator. Well, we're going to have a 2a plus 1. We're going to have a 2a minus 1. And we're going to have an a minus 1. And there we have 3 factors as our common denominator. Right. Let's rig this up with our common denominator over here. Yes, this is a long question, and yes, you've got to be absolutely accurate. All right, what's missing over here? Well, in this case, our 2a minus 1 came back because of a denominator, and it's joined by a minus 1. In the next bracket, our 2a minus 1 is joined by a 2a plus 1. And in the last term, and I'm just going to have to write it over here, we're going to have a 2a plus 1 and a 2a minus 1. And that's going to fit in on the end. Right. Let's try and get this all done in one fell swoop. Negative into 2a squared minus 1a minus another 2a's gives me minus 3a plus 1. Minus into, oh, that's difference of 2 squares. 4a squared minus 1. And our last term, which was, and let's just double check, yes, it was a plus. That's also a difference of 2 squares, 4a squared minus 1. Now, some of you will wonder why I've put the numerator in brackets. It's just to ensure that I distribute the negatives correctly. The negatives that I'm talking about, that one over there specifically, and that one over there specifically. Because if I didn't distribute them correctly, well, I wouldn't get the answer correct. So here we go. We're almost at the last step. Yes, this is a rather long question. Minus 2a squared plus 3a minus 1 minus 4a squared plus 1 plus 4a squared minus 1. Well, the 4a squared and the 4a squared can disappear. The plus 1 and the minus 1 can disappear. And what is my final answer going to land up being? Minus 2a squared plus 3a minus 1 over our 3-factor denominator. Sure, quite a question. And remember, once again, particularly with fractions, if you're accurate, you're great. If you're not, whoops, problem. Let's carry on. Here we have a couple of challenge questions. Now, challenge questions are not the everyday question. They've got a little bit of a twist to the tail. So read them carefully, and they're accessible. You've got the skills to do them. You just have to have a look and see if you can work out how. This one's fairly straightforward. We have to show that that can be simplified to that. So what I'm going to do is I'm going to start off with this little number over here, and I'm going to multiply it out and then refactorize it to get that. Well, starting with this, first squared, first times second times 2, second squared. First squared, first times second times 2, second squared. Tidying that up, 4x squared minus 4x plus 1 minus x squared plus 6x minus 9. Gathering like terms, 3x squared plus 2x minus 8. And I'm going to factorize that thing over there, and I'm going to get 3x and x, and I'm going to get minus 4 and plus 2. I've done it. There we had what we had to get, and here we've done it. Therefore, proved. Well done. Let's try another challenge question. What must be added to that over there to make it equal to this thing over here? Well, how about I multiply out this bracket first and see what I need to add? Well, first squared, first times second times 2, second squared. I could rewrite that as x squared minus x plus 4 plus 5x. So, what do I need to add to this to get that? I need to add my 5x. Answer, I need to add 5x. Now, guys and girls, on the surface, looking at that question straight away might seem incredibly difficult. But what skills did I use? I multiplied out a perfect square. First squared, first times, second times 2, second squared. You know how to do it. It's just knowing what to do when. The more you do, the easier it gets. Let's have a look at another challenge question. Evaluate that without using a calculator. Now, guys and girls, I've got to tell you, without using a calculator means if you anywhere show that you've used a calculator, can't give you any credit for the question. So, what is this going to involve? Let's have a look at the question and see if we can work out what's going on. Well, I notice that that is a perfect cube, and so is 1. Sum of perfect cubes. How about I start by factorizing? Small bracket, first, second, first squared, first times second, second squared. Because it was a plus, plus, minus, plus. And what have I got at the bottom here? Oh my goodness, I've got a factor that can fly away. So what is my final answer? If I'm going to simplify this, it's x plus 1. Now, let's have a look back at the question. They told us that x was 7.85. So 7,85 plus 1 is equal to 8,85. We didn't need a calculator for that, did we? What did we need? What we needed was a working knowledge of factorization and fractions. Okay, that's what we have time for today. I hope that you've learnt a lot. Get out there and have some fun.